Hi, today I am going to explain specifically left Riemann sum and right Riemann sum. What is Riemann sum? First of all, Riemann sum is a certain kind of approximation and integral by a finite sum. Let's start with left Riemann sum. In this graph, you can see some rectangles. Riemann sum approximation depends on addition of area of rectangles. And here you can see the rectangles. In the first example, in the first graph, we have 8 rectangles. And here rectangles are equally like. We have equal subintervals. The length of subintervals are equal. And let's say the first x value is x0 and the last one will be x8 because I have 8 rectangles. And let's say function is f of x. And if I write the integral in between x0 to x8, lower bound will be x0, upper bound will be x8, and integral is f of x dx. I will approximate this integral using left Riemann sum. I said subintervals are equally like. The length of subintervals are equal. So you can calculate the base as x8 minus x0 over 8 because you have 8 rectangles. x8 minus x0 over 8 will give you the base of rectangle. You can take a common parenthesis because all subintervals are equal. This is why subinterval is x8 minus x0 over 8. And what is the first y value? The first height value is f of x0 depends on the y value of first x value. So the height is f of x0 and f of x1. Move on. And what is the last one? Last one is f of x7 because it depends on a value before x8. It is x7. The last value is f of x7. Let's say the first x value is x0 and the other one is x4 because we have 4 equally like subintervals. And let's say function is g of x and the integral is x0 to x4 g of x dx. Approximation is one of the subinterval is x0 x4 minus x0 over 4 because we have 4 subintervals. I can take a common parenthesis, this is common. And what is the first y value? F of x0, same, g of x0, sorry, because function is g of x0, g of x0 plus g of x1 plus g of x2, and the last one is g of x3. This is the last one. Okay, we completed left Riemann sum part, and I would like to say I would like to talk about overestimation or underestimation. Here you can see that in the first figure our rectangles below the graph, and it means this is an underestimation. And I would like to write the reason. If f is increasing function, left Riemann sum is underestimate. But in the other figure we have decreasing function and our rectangles are above the graph, and this is overestimation. So if g is decreasing function, then left Riemann sum is overestimate. This is important. Okay, let's start right Riemann sum. Okay, here I have the figure again, and we have 8 rectangles, so I will use the same numbers x0, x8. The integral of x0 to x8 f of x dx will be calculated by right Riemann sum, but it will be an approximation. Okay, the base is the same because we have equal subintervals. x8 minus x0 over 8 is the base of the rectangles, and the first height is f of x1 and the other one f of x2, and the last one is f of x8. In right Riemann sum we will start from the second y value, so f of x1, f of x2, and the last one is f of x8. I will use the last y value in right Riemann sum. Okay, look at the other example. Here, let's say in the second figure we have some values, but I would like to generalize. This is why I will use again x0 and x3, and let's say function is g of x. So the integral is x0 to x3 g of x dx approximately equal, the length of rectangle will be x3 minus x0 over 3, and the first y value is g of x1 and the second one g of x2, and the last one is g of x3. Okay, this is a x approximation, right approximation. Okay, let me check the approximation, whether the approximation is overestimate or underestimate. Okay, here in the first figure I have rectangles above the graph. This is overestimate, and write the reason. If f is increasing, right Riemann sum is overestimate. In the second figure, g of x is decreasing, and we can see that rectangles are below the graph. So if g is decreasing, right Riemann sum is underestimate. Okay, we completed the graph part. I would like to show you an example of tabular Riemann sum. First, read the question. Here we have a table h of t and t, and it say use a left Riemann sum with 4 subintervals indicated by the table to approximate the integral 2 to 10 ht dt. Okay, we will approximate ht dt. The important thing is subintervals can have different lengths. This is why you have to check subintervals. Okay, look at this first subinterval. This is 1, and the other one is 2. The other one is 2, and the last one is 3. These are different, so you can take a common parenthesis. You will use these lengths, and you will calculate the area of rectangles separately. This is left Riemann sum, so I will multiply 1 with the first y value, 1.5, plus 2 with the second y value, and 2 with the third y value, and 3 with the fourth one. I won't use the last y value. If you see the graph, you can see that I didn't use the last y value, and here again I didn't use the last y value. Okay, this is the approximation. What will be the result? 1.5 4 1.5 4 12 and 33, so it will be 50.5. Okay, the other one, the second one is the same table, but we will calculate the same integral with right Riemann sum. Okay, let me check the intervals again. 1, 2, 2 and 3. In right Riemann sum, I want to use the first y value, but I will start with the second y value. So the first rectangle will be 1 times 2, and the second second area 2 times 6, plus the third one is 2 times 11, and the last one is 3 times 15. So what will be the approximation? 2 plus 12 plus 22 plus 45, and this approximation will be 81. I would like to check overestimation and underestimation. We have two examples. One of them is left Riemann sum, the other one is right Riemann sum. If we look at the results, one of them is 50.5, the other one is 81. 81 is greater than 50.5. And to understand that whether a function, whether the approximation is overestimate and underestimate, we have to check first derivative, or we have to check y values to understand whether the function is increasing or decreasing. Look at the values. 1.5, 2, 6, 11, 15. G is increasing function. If G is increasing function, then in increasing function, left Riemann sum will be underestimate. So here left Riemann sum is underestimate. And in right Riemann sum, if function is increasing, the right Riemann sum will be overestimate. It is overestimate of integrals. Thank you for listening. This is the end of the video.